Orientation. Traveling field system always try to face absorbing side forward. Proton always travel in right-hand grip rule. Electron always travel in left-hand grip rule. Our group of protons or electrons will have some extensions synchronized. Excess positive or negative trajectories extends in all angles. Proton-electron pair can only connect in certain angles for attraction. They will tilt, feed, or transfer momentum to match those angles. A field system can transfer momentum to other field system within an integrated field system. So integrated field system can adjust extensions to any required angles. A molecule with positive charge may have protons borrow momentum from electrons, but still equilibrium will be imbalanced. Thus, protons still have to find electrons elsewhere to conserve charge. Conserved charge equals balanced positive and negative trajectories. Imbalanced trajectories extend to balance synchronized momentum diffusion with surrounding, attracting opposite trajectories. Electron flow, electricity. Higher positive charge causes nearby electrons to regenerate towards it, causes atoms that lost those electrons to have higher positive charge, and the process repeats to source of higher negative charge, which is surplus electrons. That is why conductors have valence electrons, and vacuum is the best insulator. Electrons travel by left-hand grip rule. The magnetic field caused by traveling electrons is the result of multitude of electrons extensions traveling in the same direction, with the same orientation, combining and further extending synchronized momentum. Loops of electrons in electricity connect with proton, operating at nanosizes. Both these loops can be observed as electric or magnetic force. Both electric and magnetic field is simply synchronized momentum trajectories, which is perpendicular to each other. This is the main spin. Loops are secondary spins that extend to interact with vertical space. So loops are more flexible and easier to combine with other loops. Combined loops will extend further. These electric effects usually apply on smaller scale, nucleus, atom, molecular bonds, etc. Loops electric effects applies on all scale. Loops extensions are observed as magnetic force when charge is still, because loops combine easier. These extensions are observed as magnetic force when charge is moving, because these extensions are forced to synchronize and diffuse, while loops are interacting at nanoscale. Electromagnetism. Electron passing through a magnetic field experience kinetic force according to left-hand rule. Momentum in magnetic field is diverted to one side. The side increased synchronized momentum pushes conductor away, while the opposite side decreased synchronized momentum pulls conductor nearer, to balance the field of synchronized momentum. Left-hand rule is based on hypothetical motion of positive charge, so right-hand rule is a more accurate representation, based on the motion of negative charge electron, which is most of the case. Two conductors parallel to each other carrying electrons traveling in the same direction. Belts are created between the two conductors, acting like a rubber band, pulling both conductors closer. In between interfering trajectories join belts, decreasing synchronized momentum, pulling denser synchronized momentum nearer. If the two conductors are carrying charge traveling in opposite direction, trajectories will direct more momentum in between the conductors, pushing them apart, while redistributing synchronized momentum. Electroferromagnetism. Electric current traveling through solenoid forms magnetic lines. Magnetic lines coalesce into bigger geometric trajectories. A ferromagnet placed in solenoid experiences strong magnetic force, as looping wire causes magnetic lines to influence the ferromagnet repeatedly at highly compressed intensity. Its electrons rotate to accommodate absorbing and emitting orientation, synchronizing their own magnetic spins, turning itself into a strong magnet.